This is our project about making underground mines safer. We made an automatic system that checks the air and control ventilation without people having to do it manually. My name is Opeksha. My group members are Malshan, Sasmika and Alvis. What we wanted to do is build a smart system. This system watches the air all the time. If it finds dangerous gas, it turns on fans and opens the doors. If the air is safe, it slows down to save power. This is important because bad air is one of the biggest dangers in mines. If we can detect it early, we can protect workers. Also, by not running fans all the time, the mine can save a lot of electronic bills. Our system has three main points. First is the sensor part, sensor that checks gas, temperature and humidity. Second is the communication part. It sends data to computer using internet protocols. Third is the control part. It turns fans and doors on and off automatically. For sensing, we used a small computer called ESP32. We connected gas sensors like MQ2 and MQ135 to detect methane and carbon monoxide. We also use DHT11 sensor to check temperature and humidity. These small devices can be placed in different parts of the mines. Once the sensor collects data, they send it to a central server. We use a protocol called MQTT for this. MQTT is fast and light, so it works well even if the internet is slow. The server runs on this link and looks all the data. After the server checks the data, it makes a decision. If the air is bad, it sends a command to the fans and doors. We used a protocol called Modbus to talk the machine. Modbus is commonly used in factories and mines. Mines work in shift. Our system knows when a shift is active. If people are working a zone, the system gives more air and zone. If no one is there, it gives only a small amount of air to save energy. The system also knows where workers are, so it ends more air only the zones with people. Empty zones don't need much air, so the system keeps the at low airflow. This is how we cut down energy use. If the gas level goes above a safe limit, the system acts right. It increases the fan speed right away. At the same time, it sends a WhatsApp messages to the main supervisors to warn them, so they can what's happening instead. This picture shows how data move on the system. First sensor sends data to the MQTT broker. Then the backend checks the data. If needed, it ends commands to the fans and doors. We also made dashboard so you can see all the data live in our screen. MQTT is used to send sensors data because it is the simple and fast. The data is sent is JSON format. For example, one message can say zone 150 ppm. The server read this and decided what to do next. Modbus is used to control real machines like fan and motors. Most mines already use Modbus, so our system can connect to their existing equipment without changing much. It makes the system easy to do use in minerals. Let me explain the fuel process. Step 1. Sensor collect air data. Step 2. Data goes to the server. Step 3. Server checks the air is safe. Step 4. Is not safe. It turns on fans and open doors. Why do we export from this system? First, better safety with early warning. Second, less energy waste. Third, real-time monitoring on dashboard. This is our actual prototype on a breadboard. Here you can see the gas sensor, the temperature sensor and the ESP32 board. In a real mine, those would be put inside a straw safe box, but this setup shows that the idea was that our system can detect gas, make decisions and control ventilation automatically. It also sends alert to phones. For the future, we want to make the hardware safe for explosive areas, improve sensor accuracy, and explain it to cover the whole mine with one center control.
Okay, I'm going to walk you through the physical prototype we built for our automated early warning gas ventilation system. What you are looking at is the brain and sensors of our entire system, all mounted on a simple breadboard. Let's start with the sensors.
The first one is the MQ2 gas sensor. This sensor can detect smoke and flammable gases in air around it. In a real mine, this acts as our first line of defense. The moment it picks up dangerous gas levels, it sends a signal to trigger the ventilation system. Right next to it is the MQ135 gas sensor. While MQ2 handles smoke and flammable gases, the MQ135 specializes in detecting harmful gases like carbon dioxide and ammonia. Together, these two sensors give us a more complete picture of air quality underground. Moving to the center, we have the DHT11 humidity and temperature sensor. Underground mines get extremely hot and humid due to geothermal heat. This sensor constantly measures both temperature and humidity levels, and if either value crosses a safe limit, our system responds automatically. Next is light sensor module, also known as an LDR or photoresistor. You might wonder, why do we need a light sensor underground? Well, it serves as a clever backup. A sudden drop in light could indicate heavy smoke, build up, or even power failure in the mine, giving us an early warning before things get worse. And finally, connecting and controlling all of these sensors is the ESP32 microcontroller. Think of this as the brain of our prototype. It reads all the sensor data, converts it into a format that computers understand, and wirelessly sends the information to our backend server using a protocol called MQTT. It is the kind of how you phone sends message over Wi-Fi. Once that data reaches our node.js server, it checks whether any reading has crossed a safe threshold. If it has, the server automatically sends commands to speed up the ventilation fans, open ventilation doors, and even send an emergency alert to WhatsApp on notification. So in summary, this small breadboard setup is doing something very powerful. It is continuously sensing the underground atmosphere, wirelessly reporting it, and triggering automated safety responses, all without any human involvement. Now let me walk you through the web dashboard that we built to monitor and control the entire system. Control panel. First, this is the main homepage of our system. From here, operators can see if there is any emergency, stop or reset the system, and set the safety limit for gases, temperature, and light. Measurement panel. This panel shows the live sensor readings from every location in the mine. Operators can see the current temperature, humidity, carbon monoxide and methane levels and compare them with the safe baseline values. Gauge panel. This shows the same sensor data but as visual dials like a speedometer. The needle moves from green to red, making it easy to spot dangerous areas quickly. Chart panel. Moving on, this panel shows the history of sensor readings as line graphs. Operators can track how values change over time and easily identify any sudden dangerous spikes. VFD fan control panel. Now this panel controls the speed of the ventilation fans. The system automatically calculates energy savings from running fans at lower speeds. As you can see, we are saving over $2,300 per month. Shift management panel. This handles shift scheduling. Based on where miners are working, the system automatically adjusts which fans run and at what speed, avoiding unnecessary ventilation in empty areas. Door control panel. Finally, this panel controls the ventilation doors at different mine levels, ensuring fresh air is directly exactly where the miners are working. So that is our complete dashboard, from sensing danger to controlling the entire ventilation system, all from one screen.